Let's take a look at another function, a polynomial function that we can graph. We're going to take a look at f of x equals -4 times x minus 2 times x plus 3 squared times x minus 1/2 raised to the 4th power. And we want to use these ideas of finding intercepts, what happens at those intercepts, and the end behavior. So I'm going to start by finding the x-intercepts by taking each of our terms that have x's and set them equal to 0. Since this -4 doesn't have an x with it, it won't give us an x-intercept, but these three terms that do have x's can give us x-intercepts. I'm going to set the x minus 2 equal to 0. I'm going to set the x plus 3 equal to 0. And I'll set the x minus 1/2 equal to 0 to find those intercepts. For each of these, I can get x equals 2, x equals -3, and x equals a positive 1/2. So those intercepts in ordered pair form could be at 2, 0, -3, 0, and 1/2, 0. Now that we have each one of those intercepts, I want to look at the degree of each one of those terms to determine whether it's going to bounce off of that intercept or cross through that intercept. So if I look at this first term of x minus 2, it's being raised to the first power. Now, first power is just a linear function. So if I'm going to approach that intercept, I'm expected to cross over that intercept, just like a line would. The second one is at x plus 3 squared, and looking at that exponent of 2 tells me that this is going to be a parabola or a quadratic, at least happening around that intercept. It'll look like that. So quadratic, as it approaches the intercept, is going to come and bounce off. And then that third term, I've got an x minus 1/2 being raised to the 4th. A 4th power is going to act very similar to that squared power, just steeper. So it's still going to have that effect where it approaches the intercept, but then comes off on the same side of that intercept. So I would expect that to bounce off as well, or just touch that intercept and not cross over. Now, if I look back at our entire function and try to bring that into an end, I'm going to say my function f of x is approximated by the coefficient of -4, but then I'm going to combine each of my terms here. So I've got an x, I have an x to the, and I have an x to the 4th, or x squared, excuse me. And if I were to simplify each of those into a single term, that's going to give me a -4 x to the 7th power, combining those exponents, because I have a total of 7 x's. Well, an x to the 7th is an odd power graph, so I would expect my end behavior to either be in a positive slope, if it's a positive coefficient, or a negative slope with it being a negative coefficient, kind of like a linear function was. Negative coefficient, I would expect it to look like that one right there. So combining all of this together, let's put this onto a graph, what we have. So we had intercepts at -3, at 1/2, and at +2. And I know on the end behavior, my left side is going up, right side is going down, like we found right here. So that left side is going to come up, that right side is going to drop down. Now let's go left to right on those intercepts. At -3 was our second one here. We determined that it was going to bounce off of that intercept and go to the next one. I'm going to bounce off here and then approach my second intercept. At 1/2, we said it was going to bounce off again. So as I approach that, I want to make sure I get a curve on that. So I'm not coming into a hard corner, because polynomials don't have hard corners. But then I approach my next intercept, and I should cross based on what's happening. If I get 2, we decided that it was going to cross. Now, if I want to check to make sure, or if I don't remember these crossing and bouncing rules, I can always come up. Let's choose some x's and figure out some y's based on where my intercepts are. Well, to the left of my first intercept, I could have plugged in a -4. Between my first and second intercepts, maybe I plug in a 0. On the right side of my second intercept, maybe I plug in a 1. And then on the right side of my last intercept, maybe I plug in a 3. And then I could figure out some y values to go with that. And I could see that that first one would be positive, second one is positive, third interval is positive, and my fourth interval is negative. And I can determine that that's what that graph would look like based on those y values as well.